So we're going to start on the topic simple geometrical constructions. In this case, we're going to start with how to draw a perpendicular line, a perpendicular through a line. So we have a line A, B, and we want to put a perpendicular through this line. So in this case, what we shall do, you make sure you come to a point, the first point, B. You must draw an arc that is larger than the radius between these 2 points. The radius between these 2 points, the arc should be larger than the radius. As you can see, I've gotten a radius that is larger than the 2 points. And you arc. Then you come to the other point A, doing the same thing. And you draw an arc. Sorry, I chose a point that was very up. So after drawing that arc, you name the points point 1 and point 2, and you draw your line through the points where the arcs intersect. That is your perpendicular line. That's how you make a perpendicular line. So the next one, we want to divide the line AB into equal parts. Okay? Into, let me see, the length of AB is, let's get a length that is about 10 centimeters. Okay, I'm gonna remove this. So we have a new point B. And you want to divide it into 5 equal parts. So what we shall do, we shall first draw a line at an angle to this line. After this, we're going to divide this line that we've drawn at an angle. Since the length of the line is 10, since it's 10 centimeters, we're going to divide it. We're going to get a segment of 100 of 1 centimeter each. Yeah, we're going to divide this line at an angle. And I've gotten this distance. This distance is 1 centimeter on a ruler. So when you come to your point, you come to the center here. You divide it. You must be really accurate. 1, 2, 3, 4, 5. So this is called Thales theorem. It's called the Thales theorem. You come and join the last point that you got here, last segment you got, to the point B. Now, after getting that point, you come and use your 45-degree square to draw the parallel lines. Okay, maybe that angle is too stiff. You use these squares to draw the what? The lines, the parallel lines, so that they are parallel to each other. Okay, it's so bad that my book is distracting me, but so you come, you mark out this point, yes. Come and place your 45-degree square. We've marked it out, it can make that line. So all this we're doing is so that we get parallel lines, okay? Then you come and place this other square at its base so that you just slide it along to get those accurate parallel lines. Come and put it at the end like that. Now, to get the next line, you just slide this. Now this can move, okay? Come and slide this to this next point. See, go to the next point, you draw. That's parallel to the first line, okay? That's why we're doing all this technique. Slide it along this other square to the next point. Draw. Slide it to the next point. Accuracy is key when you're doing these types of drawing. This we are practicing is called the Taylor's theorem. Slide it to the next point. And these are your equal segments. 1, 2, 3, 4, 5. There are 5 segments, each of 1 centimeter from each other. So in this one, we're going to learn how to draw a parallel line to the line R. So we have this R. So we'll get a point that is approximately at the center of this line. Say this point A. And we want to draw a parallel line through a point, through this point. This point is B. So what we shall do is go to our approximate intersection and draw a semicircle through the point B. So when you've gotten that, you draw a semicircle through the point B. You notice I'm using very light arcs. Don't over thicken them, because the thickening is, the outlines are for when you have finished drawing what you want. The parallel line that we're looking for is the one we shall thicken. So we have our arc which has created a point P and Q on our line R. So we come to our point P and we draw an arc through the point B. So we arc from P to B, and we take that same distance that we've arced to Q, and we arc it on that semicircle, and we'll call that point C. So here it's very easy. You just simply come and draw a line through these 2 points B and C, which is now our parallel line. Now that our parallel line, we name it S. This line S is parallel to the line R, and you can see I bolded it nicely. Okay, yeah. So in this next example, in this next lesson, we want to draw perpendicular lines at a point A and at a point B, and also parallel lines through the line AB using set squares. Okay, using the method of what? Set squares. So here we have our 45-degree set square. We place it along the line AB. Yes, after placing it along the line AB, you get your 30-degree set square. Now you have to make sure that when you're using your set squares, you're always keeping them well, because they must be always accurate. The edges have to be good and well kept. Okay, so you place the 30-degree hypotenuse along this line. You see the hypotenuse of the 45-degree set square is on the line. Then you place the hypotenuse of the 30-degree set square along this line, and then you flip the square by 90 degrees like that. Okay, my line it's not enough, so what we shall do, we'll take it over to the point B. I want to take it to A, but this space is not enough, so we'll take it over to a point B. See? So we slide this 90-degree over to the side B to draw the perpendicular. After getting that line, you can draw out your perpendicular line along B. Now, I think you've seen that, okay? That's the perpendicular line. And to test that it's perpendicular, you simply bring the 45-degree and put it there you can see it suits it perfectly. It's 90 degrees when using the square to test it. Then if you want to slide this line to make parallel to the other, you simply just get this set square, one of them, you can use any of them. You use this set square and slide it, place this one under. Remember how we drew the other parallel line? Place this one under like that, and then slide to the point A. Okay, and that's our 90 degrees. So this line is parallel to this. Hope you've learned how to use the squares. You simply use your two squares, the 45 degree and the 30 degree square, to make these lines. So to test this perpendicularity, you just simply come and put the edge of the 35 degree set square there, and as you can see, it's a perfect perpendicular. You come and put your angle. Okay, so that's basically it. So so for this lesson, we want to draw a perpendicular line through point A using our compass. So what we shall do, we'll come here and draw an arc of any radius through our line AB. Okay, and we'll name this point C. We get that same radius, come to point C, we note another point D. We maintain the same radius, we come, we note another arc, and we note where it crosses that arc C, we note that point E. Then we come to this point E, maintaining the same radius. So you can see it can pass through D. You come and make another arc, and that arc is called, that point is called F. Now, when you come here and you draw a line through this point F that was made and this point A, it should be perpendicular. And to test this, you simply bring your 45 degree square and place it along there to check the perpendicularity. As you can see, it's perpendicular. The lines run along the 45 degree square on its 90 degree side. Okay, it's accurate. So you come and put the sign for the symbol for the 90 degrees, which is an arc with a dot in the middle. And that's our way of constructing a perpendicular through a point A on a line. Okay, so in this lesson here, in the last lecture, we learned how to make a 90 degree, and here we're going to learn how to make 60 degrees and 30 degrees, and also here we'll make 45 degrees. So on this line S, let's make our 60 degrees through a point A on the line S. So we pick any radius, any that can be cut along this line. We arc, point, and we maintain the same radius. We come to the new point that it has made, and we arc. Now, this point that it has made, this is a point B, this is a point C. This point that it has made, when we draw a line through this point, it is our 60 degrees. So this is our 60 degrees. If we want to make 30 degrees, we simply intersect these two. So come at a point B, same radius. I'm using the same exact radius we used to make the 60 degrees. We continue the arc, and then we come to the point C. And we make another arc. The point where these two arcs intersect is our 30 degrees. So let's draw that line through the 30 degrees. This angle is 30 degrees. If you want to divide it further, you even go further, okay? You go further. If you want to divide it, you just repeat the same process, okay? And also for the 90 degrees, if you want to make this 45 degrees, you just come to the point C, you make an arc which passes through the point D. I've not changed the radius, I'm using the same exact radius, that's why you see it's flawless. And then you come to this point, same radius, don't change the radius. You arc, where they intersect is your 45 degrees. This is 45 degrees. Okay, if you want to divide it further, you do the same exact procedure until the angle that you want. So we have our circle O with a center O, and we want to draw a tangent in the direction, this direction, along the circle. Okay, so what we shall do, we'll get our 45 square, and first we'll get our 45 square and we'll get its edge to run along the tangent line that we want, the directional tangent line, this line. So we slide this remember, this makes 90 degrees to the tangent, okay, to the line we're drawing. I'm just trying to make a perpendicular line to this tangent through this, the center of the circle. So I slide this square, the 45-degree square, along to this point, to the center. Okay, this edge is interacting with my circle, so let me just use a ruler to complete it. So this makes our 90 degrees. Okay, now after we've made that 90 degrees, where then this line, you have to make sure that this line cuts across the circumference of the circle. So we have this point. We have this point. Because if I didn't have that distraction of the edge of the book, I would have drawn it, but I don't. So we have to draw a tangent through this point and this point. Okay, now if you remember the principle of drawing our parallel lines, we just simply get our set squares, one of them we put along this line, okay, because we're trying to put this tangent along the circles. So this is the line that is going to be dragged to be parallel to those points that we've gotten, okay, the perpendicular points. So we draw a tangent through here. This is the tangent we're looking for. We have to use outlines on it, and then there is this tangent. These lines we're drawing are perpendicular to the tangent D. Never forget that. Yes. So this is T1 point T2. These are all tangents that are parallel to each other, RS. So that's how we put a tangent when we're given a directional line, okay? So in this point, in this lecture, in this lesson, we're going to draw parallel line to the line, to this line R, which is a distance apart, by the distance D apart from each other, two parallel lines, using a compass and a ruler. So at first we'll get our any radius through the point A along this line R, and inscribe an arc, okay, Then to make 2 points, we go to the first point. This first point, we get a radius that is bigger than the first arc we made, okay? And we make an, sorry, my compass is sliding. So we come to point R, this point we made, radius that is bigger than our first radius, and we make an arc. Then we come to the other corner that the first arc made, the second point, with the same radius that we've just subscribed, and draw an arc, and it will make a point B. Now this point B, where these two arcs intersect, will be perpendicular to the line R. So we join the point A and point B. To make perpendicular line, 90 degrees. So after that, we're going to go and get our distance, this distance D, because the parallel lines have to be apart by this distance. Okay, that distance, you come to point A and you mark along the perpendicular line we made, this point. Let's name that point C, where it intersects the perpendicular. You come to this point C on the perpendicular line. And you make a big, any circle, any radius that can cut across this line, our line R. And cuts the line R at a point D. We go to our point D with the same exact radius that we've just arced, and we make another arc on the other side of this same line R, and it will cut through C because they have the same radius. Okay, and the point where this other arc cuts the line R, we'll name this point E. Now we'll get this distance CE, okay, and come to the point D and scribe along that arc that we made with the other radius, and we'll name that point F. Now when you get your ruler and you draw a line through point F and point C, it will be, we'll draw a line through it, and this line has an outline which is parallel to the line R. Let's name this line S at a distance D. The distance between these two lines is the distance D. That's how you make a parallel line of a known distance. So we have our random points A, B, C. Here we want to make a circle that passes through all these random points. So the first thing we shall do is to draw a line through A and B. Okay, and draw a line through A and C. Now, after I draw those lines, you now come to a point A. We're going to draw a perpendicular line through a line AB, okay? Come to a point A, and we get a random radius that is larger than its midpoint, and we draw an arc, okay? We also come to point B, and we draw an arc. Same radius, okay? Don't change the radius, okay? And we'll draw a line through the intersections of the arcs. Yes, you come to the line AC, you do the same exact thing. You draw an arc that is larger than its midpoint, the midpoint of AC, okay? Maintain the same radius, come to point A, draw. The point where these arcs meet that we've just drawn, we'll draw a line through them to make a line that is perpendicular to the line AC. So, where these two perpendicular lines meet will be a point O. That point O is that point O you stretch it to one of the points, either A or B or C, that the random points we had, and that will be the radius of our circle. And you can see that it passes through all the points. If you're accurate, it will pass through all the points. If you're not accurate, it will not pass through all the points. So that is our circle, given 3 points, random points.